dear students. Today we are going to solve next question from HSC Board, haloalkane, haloarine. Okay, for your reference, the question on page number 243. Now the next question is, name the reagent used to bring about the following conversions. Okay, so let's start. Bromoethane to ethoxyethane. So let's solve it. Bromoethane to ethoxyethane. So first let's draw the structure of bromoethane. So CH3 CH2 Br, it is bromoethane, and we have to convert this bromoethane to ethoxyethane. Ethoxyethane is CH3 CH2O. Now this part is ethoxy and then ethane, so CH2 CH3. So we have to convert this alkyl halide into ether. Ethoxyethane is what? Ether. So we have to convert halides to ether. Now to convert alkyl halide into ether, we have one specific name reaction, and that is Williamson synthesis. Okay, so let's start. See, this part CH3CH2 and this CH3CH2, this part is from alkyl halide. Now what we have to get? We have to get this part, OCH2CH3. Now from where we can get it? The solution is here, CH3 CH2OH. Okay, now I have taken alcohol first. Now I am going to heat this alcohol with sodium. Now what will happen? We will get 2 times CH3 CH2O and Na, and plus H2 gas will evolve. Now what we have? We have sodium and ethoxide. So sodium ethoxide. Now next step is we have to react our starting material ethyl bromide with sodium ethoxide, means NaO CH2 CH3, and now we get CH3 CH2O CH2 CH3 plus NaBr. So this is the method of preparation. So in that question they have asked us to write down a reagent. Okay, so the reagent will be sodium ethoxide. In simply you can say reagent is sodium ethoxide. But you can remember this whole procedure, so you can apply in the next problem. Now next question is 1 chloropropane to 1 nitropropane. Okay, 1 chloropropane to 1 nitropropane. So let's first draw the structure. 1 chloropropane. So CH3, CH2, CH2 and Cl. Now this name of this compound is 1 chloropropane. 1 chloropropane to 1 nitropropane means CH3, CH2, CH2 and NO2. See, they have asked us to convert nitro. So connection to carbon is through nitrogen. So the name of this compound is 1 nitropropane. Now how to convert this? We just have to heat this compound with AgNO2. Okay, we have to just react this compound with AgNO2. So 1 chloropropane can be converted to 1 nitropropane when we treat it with sodium nitrite. Now let's see the next problem. Ethyl bromide to ethyl isocyanide. Okay, ethyl bromide. Now let's draw the structure. Ethyl bromide. Ethyl bromide is what? CH3 CH2 Br, and we have to convert that into ethyl isocyanide. Okay, ethyl isocyanide means CH3 CH2 N triple bond C, because it is isocyanide. If they ask you to convert it into CH3 CH2 C triple bond N, then it is cyanide. Okay, and when it is N triple bond C, it is isocyanide. Remember. Now we have to convert CH3 CH2 Br to CH3 CH2 N triple bond C. Now how to convert it? We just have to react it with Ag N triple bond C, silver isocyanide, and we will get CH3 CH2 N triple bond C. If we ask to convert this ethyl bromide to ethyl cyanide, then just we have to treat the compound with potassium cyanide. Okay, just a minute. Now you have seen the difference between isocyanide and a cyanide. Now we will convert this ethyl bromide into isocyanide as well as into cyanide. So whenever alkyl halide is converted to alkyl cyanide, it is always treated with alcoholic KCN. Remember, alcoholic KCN. See, ethyl bromide can be converted to ethyl isocyanide. Okay, so remember, halides can be converted to isocyanide when we treat it with AgCN, and halides can be converted to cyanide when we treat it with KCN. Now next problem. Next problem is chlorobenzene to biphenyl. Okay, chlorobenzene. So this is the structure of chlorobenzene, and we have to convert it into biphenyl. So now I am drawing structure of biphenyl. This is biphenyl. Okay, so we know Wood's reaction. In Wood's reaction, what we do? RCl means aliphatic alkyl halides are treated with sodium. Okay, and then we get alkane, higher alkanes, right? Similarly, this aryl halides also can be coupled with the help of Fittig reaction. Okay, so what we have to do, this aryl halide we have to treat with sodium. In presence of ether, we get biphenyl. So it's a simple reaction, just like a Wood's reaction. And this is name reaction. This reaction is Fittig reaction. Remember, aryl halide can be coupled with the when we treat it with sodium in presence of dry ether, and we get coupled product. The reaction is called as Fittig reaction. So now let's move to the next question. Yes, now next question is, arrange the following in the increasing order of boiling point. Okay, 1 bromopropane, 2 bromopropane, 1 bromobutane, and 1 bromo 2 methyl propane. Okay, so let's draw the structures first. Okay, so first is 1 bromopropane. So CH3, CH2, CH2 and Br. Now next is 2 bromopropane. CH3, CH, Br, CH3. Now 1 bromobutane. CH3, CH2, CH2, CH2 and Br. And the last structure is 1 bromo 2 methyl propane. Okay, so 1 bromo, then 2 methyl, and then this is propane. Okay, so these compounds we have, and we have to arrange the boiling point order. So always remember, long chains always have higher boiling point than the branched one. Okay, so first check the number of carbon atoms. So more the number of carbon atom, and if they are present in the straight line, they will be having higher boiling point. Okay, so we have these two compounds which are straight chain. So this will be 1 because these in this compound there are 4 carbon atoms, and this will be second because there are 3 carbon atoms and they are present in a straight chain. Now we have this compound having 3 bonds, 3 carbon and 1 bromine, and we have the 4 carbon with 1 bromine. So now where the branching is more, boiling point decreases. So this will be 3 and this will be 4. So more the branching, lower the boiling point. Van der Waals force of attraction between the molecule decreases. The molecule come closer, and the rate at which heat transfer is more. So we need to give less amount of heat to boil the compound, and that's why it will be having lower boiling point. So one bromobutane, then 1 bromopropane, then 2 bromopropane, and then 2 methyl 1 bromopropane. So this will be the sequence of boiling points. Now next question is match the following pairs. Okay, so let's see, I'll explain you. So if it is CH3, CH, CH3 and X, so this is simple alkyl halide. Why alkyl halide? Because we have removed one hydrogen from alkane and we have added one halide. Okay, now CH2 double bond CH2 is vinyl, and if we remove one hydrogen from vinyl and if we add one halogen to that, the compound is called as vinyl halide. Okay, now next, if there are there there are compounds like CH3, CH double bond CH2. Now this arrangement is called as allyl, and if you replace one hydrogen of allyl with halogen, now this compound is called as allyl halide. Okay, so remember, when halogen is directly attached to sp2 hybridized carbon atom, okay, of alkene, it is called as vinyl halide. When halogen is attached to sp3 carbon which is placed next to carbon carbon double bond, it is called as allyl halide. And alkyl halide means simply we replace one hydrogen of any alkane by halides.